Hello students, so this is a question from process management and it's a 2 marks question. Okay, so the question is, let S be a semaphore initialized to 2 and 3 processes XYZ are accessing the integer variable X as shown below. Okay, so there is this semaphore S which is initialized to 2. That means maximum 2 processes can go inside critical section. Okay, and there are total 3 processes which are given to us, X, Y and Z. So let's see this processes weight. So we are applying weight on to the S before entering into the critical section. Then we are reading the value of X, we are performing some operation on X, and then we are writing that value back into the memory. Okay, and then we are calling the signal of S. That means we are changing that semaphore, we are increasing that semaphore's value. Okay, the question is, if X is initialized to 0, how many possible values can X have after execution of all processes once? Okay, so let's assume that X is initialized to 0. So the question is, because they are accessing the critical section and because we are allowing more than one processes to go inside critical section, there is a possibility that there might be more than one possible values which might be written into the memory. Okay, so we want to find those possible values, the number of possible values that X can have after execution of all processes once. Okay, so only thing to note here is that all writes may not go inside memory, okay, or critical section. Okay, so because we are accessing the critical section, it is not necessary that all your writes will go into the memory. Okay, so let's assume that all the writes goes into the memory and we are accessing these processes are going into the critical section one by one. Okay, so let's assume that XYZ all writes are going into the memory. So because X is initialized to 0, this process will increment it by 2, then decrement, the next process will decrement it by 1, the next process will decrement that by 3. So the answer, final answer which will be written will be -2. Okay, similarly let's assume that only one write goes into the memory. Okay, so let's see how this can happen. So it may happen that this process enters into the critical section. Okay, meanwhile this process reads the value of X, so this process reads the old value of X. Okay, then this process comes out of the critical section. At the same time this process goes into the critical section and also this process comes out of critical section. That means X and Z writes the value of X, but Y and Z writes the value of X, but X has already read the old value of X. Okay, and X will come out last. That means the final write which will go into the memory will be done by process X. Okay, so if only one write goes which is done by X, the value of X will be 2. Similarly, if only one write goes which is written by Y, then value of X will be -1. Similarly, if only one write goes into the memory which is performed by process Z, then value of X will be -3. Okay, so similarly let's assume that there are only two processes, only the writes of 2 processes goes into the memory. So it may be XY, it may be YZ, or it may be XZ. Okay, so if the writes of X and Y goes into the memory, the value of X will be 2 minus 1 equals to 1. In case of YZ, it will be -1 minus 3 equals to -4. In case of XZ, it will be 2 minus 3 equals to -1. Okay, so the question is how many values. So depending on when the processes are accessing their critical sections and whether their writes are going into the memory or not, whether their writes are read by the other processes or not, there can be different values of X. Okay, after execution of all processes once. Okay, so we want to find the possible values. So -2 is the one possible value. Okay, +2 -1 3. So there is this +2 -1 -3 Okay, then there is this plus 1, so plus 1, minus 4 and minus 1, which is already here. So that means this many values are possible. So total number of possible values are 6. Okay, so how many different values are possible? So the answer is 6. So there can be 6 different values of x, because we are allowing more than one process to access the critical section. So depending on the sequence in which they are accessing the critical section, as well as whether their writes are read by the other processes or not, depending on that, there might be one of these 6 values which will go into the memory. Thank you.